this section, we're going to talk about the domain and multiplication and division of rational expressions. A rational expression is basically a fraction. When it comes to domains and you have fractions, can't divide by 0. So the instructions here are or is to define the domain. The numerator can be anything. It can be 0. And 0 over 7 is 0. It's well defined. You just can't divide by 0. Whatever is in the denominator, it can't be 0. And we should solve this equation or non-equality for x. That is, add, if you don't want 0, then these two numbers shouldn't be the same. So when you subtract the same numbers, bingo, you get 0. So just don't let x be 41. And there's the final answer. If you wanted to write this answer, you wanted to graph the answer. Well, here's 41. You can't be 41, but you can be below 41 or above 41. You want interval notation? This interval right here is from negative infinity up to 41, but don't include it. That means open bracket. Never ever include infinity. And then the other half, or you can be in the other half, which is 41 on forever. That means up to infinity. Never ever include infinity. And in this case, don't include 41. The only number that isn't in one of those intervals is 41. 11 is in this interval. Negative 55 is in this interval. 108.3 is here. The square root of 2,311,421 is here. The square root of 11 is here. The only number that isn't in one of those two intervals is 41. You have x plus 5 divided by x squared minus 9. Well, the domain is the denominator can't be equal to 0. Okay, even if you can't go any further, at least state that. Okay, if you factor this is x squared minus, and this is can be realized as 3 squared. The x and 3, they each go in brackets. One with a minus sign, one with a plus. You don't want this to be 0. Well, if you don't want this times that to be 0, then you don't want this to be 0 or that to be 0. Well, this is 0 when x is 3. Don't allow it. Or this is 0 when x is negative 3. Don't allow that. Don't allow x to be negative 3. Otherwise, the product will be 0. Don't let the denominator equal 0. So basically, it's just like a factoring problem. Find the zeros of the denominators. Now, suppose you were asked to simplify. Now, I'm really picky on these type problems. 3x minus 4x squared. Well, you should try to factor the top, which cannot be factored. You can try to factor the bottom, and you can factor out an x. X times 3 really does give you 3x. Minus minus. X times 4x really is 4x squared. A lot of students would just say, oh, the x's cancel, and you get 3 over 3 minus 4x. That is this and that, they're equal. Okay, somebody asked me, what is this equal when x is 5? Well, you have two options. You can plug 5 in for x. Whenever you see x, plug in 5. This is 15, and that's 15, and that's 100. 5 squared is 25, 425 is 100. 15 minus 100 is negative 85, which is a negative number. 5 goes in here 3 times, 5 goes in here 17 times. Negative 3 over 17. You can do it that way. It would have been easier if you used this one. You get 3 over 3 minus 4 times x, which is 5. This is 3, that's 20. And 3 minus 20 happens to be negative 17. And understood positive divided by negative is negative 3 over 17. The only thing is that that last equal sign on the top, in my opinion, is not valid. For example, if x is 0, the left one gives us 3 times 0 over 3 times x minus 4 times x squared. This is 0. This is 0 minus this is 0. This is 0 over 0, which of course is indeterminate. Problem is, this is not. The right hand side is not. It's 3 minus 4 zeros. 3 minus 4 times 0, which is 3 over 3 minus 0, which is 3 over 3, which is 1, which is not indeterminate. We're not getting the same answer. So, the two things do not always give the same answer. You don't put the horizontal lines in between them. Now, let me be clear about that. We're trying to say right now that this and this are exactly the same. If somebody asks you, this, this statement is not always true. This is a conditional equation. This equal sign is valid only if x is 2. 3 plus 2 is 5. It's only valid if x is 2. That's not what we have on top here. We're saying that they are the same. We're saying they're the same. They're not. They're not. Always we're saying they're the same. This and this are the same, provided that is under the condition that x is 2. That's a big condition. Okay? But they're not the same. When x was 0, they weren't the same. The thing is that x over x is not 1. You can stand on your head. I'm not going to give into that. Remember, I crossed off x over x here as if it were 1. It's not 1. If x is 5, I'm not going to argue with you. I'm stupid. 5 over 5 is 1. Negative 3 over negative 3 is 1. But 0 over 0 is not 1. 0 over 0 is not 1. X over x is a piecewise function. It's 1 provided that x is not 0. If x is 0, it's indeterminate. You have x minus 4 over x minus 4. A lot of students want to say, oh, I know this one. It's 1 if x is not 0, and it's indeterminate if x is 0. Well, that's not true. I mean, just get your hands dirty. 0 minus 4 is negative 4. If x is 0, 0 minus 4 is negative 4. This is 1. It's not indeterminate. It's indeterminate if the top and bottom are 0. Well, the top is 0 when x is 4. 4 minus 4 is 0. Okay, so it's just the number 0 that's incorrect, but that's the big difference. It's 1 if x is not 4. But if x is 4, you plug 4 in for the top. 4 minus 4 is 0. The bottom, 4 minus 4 is 0. That's indeterminate. Well, if you cross this out and call it 1, you better, that may not be correct. That may not be correct. Okay, you have to be careful. We crossed off x over x as if it's 1. But unfortunately, we crossed off x over x as if it's 1. But unfortunately, it's not always 1. So, what you need to do is write the following. If your teacher doesn't tell you to do this, your teacher is absolutely wrong. Equal signs have to have some meaning. This is 3x over x times 3 minus 4x. Now, as long as x is not 0, you can call that 1. And this is what you get. But you really should say the condition on the equal sign. Some people, instead of writing it above the equal sign, they would write here, provided that x is not 0. You can put it here, you can put it there. I personally like to put it there, so it's very clear. Nobody thinks that, oh, I didn't understand that. It's equal, those two sides are equal, provided x is not 0. So when they say simplify, you really have to say things like this. You have x take away 3 divided by x squared plus 4x minus 21. Well, you can factor x minus 3. Instructions are still to simplify. But in the bottom, since you have x squared or 1x squared, we'll try to factor it as x followed by a number times x followed by a number. And the two numbers should multiply out to the constant. They add up to the number in front of x. And two numbers that multiply out to negative 21 that add up to our 4 are negative 3 and 7. Negative 3 and positive 7. Okay. You can put brackets, that's not a big deal. You can cross this out and call it 1, provided x is not 3. And then you get what you get, 1 over x plus 7. Now, I much rather use this than this. If x is 5, I don't want to do 5 minus 3 over 5 squared plus 4 5s minus 21. I'd rather use this one. 1 over 5 plus 7, 1/12. Done. They're equal. They're equal. Provided x is not 3. On the left side, you're going to get 0. Remember, this equal sign is always right. You plug in 0, you get 0 on top. I meant to say 3. You plug in 3. You get 0 over 0 times 10, which is 0 over 0, which is indeterminate. But on the right-hand side, you plug in 3. 3 plus 7 is 10. You get 1/10. They're not equal, and you just can't write equal when things aren't equal. Okay, so they're equal. It equals 1 over x plus 7, provided that x is different, that is not equal to the number 3. Don't just put equal signs all the time. Look at this one. Suppose you have 3r minus 5 over 5 minus 3r. 3 minus 7, the top is 4, the bottom is negative 4, and understood positive divided by negative is negative, and 4 over 4 is 1, negative 1. If you have 13 minus 15 divided by 15 minus 13, the top is negative 2, the bottom is 2, which means positive 2. 15 minus 13 is 2. In division, the signs are different. It's negative. 2 over 2, 1. It's negative 1. In the top, we can factor out a negative sign. And we get negative 5, just like we're supposed to. And we get negative 3r. That makes it plus 3r. The reason we're doing that is because now what's in the bracket on top is the same as what's in the bracket in the bottom. And except when it's indeterminate, this cancels out to 1. But there is a negative sign in front. It's negative 1. But there's a condition. There definitely is a condition. Sometimes 5 minus 3r is equal to 0. And then it would be 0 over 0 that we cancel that. Remember, if you subtract two things and you get 0, then the two things must be equal to one another. Divide by 3, and you get what r would equal. When r equals 5/3, cannot equal, excuse me. You get 0 over 0. When r equals 5/3, 5 minus 3r is 0. Top and bottom. 5 minus 3r is 0. 5 minus 3r is 0. Cross them out. Don't get 0. Excuse me, don't get 1. Get 0 over 0, which is indeterminate. This is equal to negative 1, provided that r is different and is not equal to 5/3. It really needs to say that. If your teacher says otherwise, teacher doesn't write that, well, challenge your teacher. Say, for what about when r equals 5/3? You don't get negative 1, you get indeterminate. And the teacher says, oh, yeah, you're right. But, you know, debate that, but you have equal sign. You can't have equal sign if they're not equal. Okay, suppose you have something like this. 2x minus 5 times 3x plus 11 minus 2x minus 5 times x minus 12. And all of this gets divided by 2x minus 5. Well, in the numerator, it's this term minus this term. Terms are separated by addition, subtraction symbols that are in brackets. Okay. Now, the left term is made up for factors, things that are being multiplied. What's in the first bracket times what's in the second bracket. Second term is made up for factors. This factor times that factor. Do the two terms have any factors in common? The answer is yes. They both have 2x minus 5 in common. So you factor it out. The 2x minus 5 in the first term is being multiplied by 3x plus 11 minus, and 2x minus 5 in the second term is being multiplied by x take away 12. All of this gets divided by 2x minus 5. Okay, let's do a little arithmetic by cleaning up what's inside the second bracket, the big bracket here. You have 3x, and you are taking away x. That leaves you with 2x. You have 11, and you are taking away negative 12. And you're adding 12. 11 plus 12, 23. Now, most times, that will be 1. And you will be left with 2x plus 23. But there is one time when you won't get back 1. And that's when this is 0 and that's 0. That's when 2x is equal to 5. That's when this equals that. Divide by 2, that's when x is 5 halves. X cannot equal 5 halves. Okay, you plug 5 halves in here, you get 28. Get a nice number. You plug 5 halves in here, you get 0 times 28 divided by 0. That's 0 over 0. It's indeterminate. What's in the left box is not equal to what's in the right box. Not all the time. Not when x is 5 over 2. So just write it. Say x cannot be 5 over 2. One of the reasons students sometimes think dividing by 0 is okay is because their teachers aren't drilling it into them. Yeah, they say all the time, can't divide by 0, can't divide by 0. But yet, they'll say x minus 5 over x minus 5 is 1. Okay. So, let's do some multiplication problems. Suppose you have 3x squared over 7y, and you're multiplying this by 4y to the 5th over 7x. Now, let's see if I want to do that. Okay. Well, the fact is, now this is the same as, this is the same as 3x squared. I meant to write there 4 next, after the x squared. I just blew it. Over 7y, 7x. That is, when you multiply 2/3 by 5 over 7, isn't it? 2 times 5 over 3 times 7. It doesn't need to be a separation here. Somebody asks you what 2/3 times 5/7 is. You can see that. Just extend it. Where the cost is not 25 over 37. And now you try your best to reduce. Y, I kill off one y in the bottom and one y on the top. But remember, that's only true provided y is not 0. 1x on the bottom, one of the two x's on top, leaving 1x. So what survived is 3. So x cannot be 0. 3 times 4 is 12 times x times y to the 4th. On the bottom, 7 times 7, 49. On the right-hand side, what I just circled, it's well defined when x is 0 or y is 0, but even when both of them are 0. But on the left side, it's not well defined. If y is 0 and x is 1, 3 times 1 squared is 1, divided by 7 times 0. You can multiply two numbers when the first one makes no sense. So that's a multiplication problem. we're asked to multiply these two fractions. First thing you should do is factor each of them. When you factor the numerator, since it's p squared and not 3p squared, we play the p followed by number game times p followed by number game. And on two numbers that multiply out to the constant, they add up to the number in front of x. In front of p. The answer is 5 and 2. 5 and 2 multiply out to 10, add up to 7. Plus 5 plus 2. P plus 4, you factor that, but it can't be factored. Notice I didn't put any separation between the two numerators. In the bottom, p plus 5 cannot be factored any times. P plus 2 cannot be factored any. Okay. Your textbook might just say p plus 4. It's wrong. It's absolutely wrong. Sorry. This is not always 1. Not when p is negative 2, so I won't let it be 2. This is not always 1. And I crossed it off as if it were 1. 1 times p plus 4, just what I said the answer was. But again, p plus 5 over p plus 5 is not always 1. Not when p is negative 5. So you should write your answer like that. Or you can say equals to p plus 4, comma, p is not negative 2. P is not negative 5. Just list what p can be. There are some numbers that p just can't be the way it is. P can be most numbers, and you'll get p plus 4. So again, to really emphasize this, a lot of students would do the following. If somebody asked you, and this, I'm talking about after we did all the work we've done, somebody asked you, what does this equal when p is 10? There's absolutely no reason to go, 10 squared is 100, 7 times 10 is 70, 100 plus 70 is 170, plus 10 is 180, and in the bottom, 10 plus 5 is 15, and this is 12. Well, that makes no sense. I said p is 10, right? 180. Oh, excuse me. I forgot this piece. Times 14 over 12, and then go that 15 goes in here 12 times, and 12 goes into 12 one time. 1 times 14 is 14. I was able to do that fairly quickly. For you guys, it'll be a lot harder. I'd go to what it simplifies out to. 10 plus 4, 14. Much, much easier to get 14. But you need to know when you can use p plus 4. You can only use it if p is not negative 2 or p is not equal to negative 5. And if you write that they're equal, people should believe that they're equal. But they're not. Not when p is, I think, negative 2 nor negative 5. They're really, truly not equal. Now, somebody gave you a division problem. Say a minus b over, I don't know, 9a plus 9b, and you want to divide this by a squared minus b squared over a squared plus 2a plus 1. The first thing you should do is convert it to a multiplication problem. You keep this the same way, you change that, and you flip this. So you have a minus b over 9a plus 9b times, flip this, and then you factor. You cannot factor a minus b. You can factor that, since it's a followed by a number, since it's 1a squared, it's a followed by a number times a followed by a number. The two numbers should multiply out to positive 1 and add up to positive 2. Those numbers are 1 and 1. 1 times 1 is 1, 1 plus 1 is 2. In the bottom, you can factor out a 9 from here. 9 times a plus 9 times b. Exactly what it said. And this is a squared minus b squared. So you put a and b in one bracket and a and b in the second bracket. One gets a plus, one gets a minus. And then you say that cancels out. But that's provided that a is not equal to b. And if I'm not mistaken, that's all that we can factor out. So we get a plus 1 times a plus 1, which is a plus 1 squared, divided by the 9, times a plus b times a plus b. The numerator, as I said, should be a plus 1. I'll change that. The bottom is 9 times a plus b times a plus b, which is 9 times a plus b squared. There's an answer. That mess on the very top is equal to this, provided a and b are different. So now we just don't have one or two values that the variables can't be. There's infinitely many values. If a is equal to 2/3 and b is equal to 2/3, then you can't use this rule. If a is equal to 23/3 and b is 23/3, you can't use this rule. Provided a and b are different numbers, you can use this rule. If I tell you a is 4 and b is 5, and I ask you, what does this division equal? I doubt anyone would use this rule. I bet people would use this rule. But it's best to use this one. A is 4. 4 plus 1 is 5 squared, get 25 over 9 times. A plus b. 4 plus 5 is 9. Square it, get 81. 25 over 729. A lot easier than using this rule or that rule. Even if you did use the top rule, the first thing you would do after you found out the numbers would be to invert it. But it's a lot easier to use this rule. But you better know you can't use it when a and b are equal to one another. If you subtract two values and you get 0, I claim that this is a big fact. This is a fact. If a minus b is 0, then a equals b. And the proof, the verification of this fact is actually very elementary. Just add the same to both sides. Add b to both sides. A equals b. If a minus b is 0, then a equals b. this by x squared minus 2xy plus y squared. And then in turn, divide this by x squared plus y squared. Squared plus y squared divided by x to the fourth minus y to the fourth. Okay, so let's get it to be multiplication. You keep this, you change that, and you flip this. X squared minus y squared over this times x squared plus y squared over x to the fourth minus y to the fourth. Now, there's absolutely no reason to really separate this. You can even move the factors closer to one another. Okay, x squared minus y squared. X and y are being squared, and there's a necessary minus in between. So you write x and y in one bracket, x and y in the second bracket. One gets a minus, one gets a plus. The sum of things being squared, like x squared and y squared, can't factor. X to the fourth minus y to the fourth. Do that one on the side. X to the fourth is x squared squared minus y squared squared. Don't worry what's in the bracket. Don't worry that, oh my, what's in the bracket is being squared. Excuse me. Something in the bracket is being squared, like x. I couldn't care less what's in the brackets. But it's being squared. Minus what's in the bracket is being squared. So I write down what's in the brackets 2 times in its own brackets. One gets a minus, one gets a plus. This can be factored. This is x plus y times x minus y. In fact, it turned out it didn't even have to factor the x squared minus y squared, because there was an x squared minus y squared in there. Okay, and the x squared plus y squared cannot be factored. So you have x plus y, x minus y, x squared plus y squared. And then we have one more factor to deal with. X squared minus 2xy plus y squared. One way of thinking how to do this is x squared. So you only want to see x's. When you have the x term, you have y. And in the constant, I mean, there's an understood one there. But in the constant, you have that y squared. That tells you temporarily you could ignore the y's. Plus 1, excuse me. You could ignore the y and the y squared. And factor this. X squared, that means x followed by number, x followed by number. The 2 numbers multiply out to 1, but add up to negative 2. Well, that's negative 1. But then go back to the linear, go back to the x. That was a y here, so we plug y in our answer. It's x minus y squared. X minus y squared. Okay, let us write down the answer. Make a long equal sign because we are going to have to write down the conditions for this equal sign. Now, x squared plus y squared. When is that 0? And that's when x equals 0 and y equals 0. Okay. Now, when, if ever, is this 0? X plus y equals 0. If I bring the plus y to the other side, I get negative y. X cannot be negative y. Now notice on the top, this and is very important. I'm not saying x can't be 0. X can be 0. I'm not saying y can't be 0. In fact, y can be 0. What I am saying is they both can't be 0. Okay, x cannot equal negative y. Now, x minus y and x minus y, I'm going to say that cancels out to 1. But only if it's not 0. That means x cannot be y. X cannot be y. Okay. And if that's all true, well, the numerators just have 1 over x minus 2 times 1 times 1 times 1. It's 1 over x minus y squared. Okay, now, if you want to be really slick, I claim that you can remove this restriction and just say x cannot be negative y and x cannot be y. Okay, think about why I'm saying that. Remember, if x can't equal y, well then they both can't equal 0. This is redundant saying this. If x can't equal y, well then x can be 3 and y can be 3 at the same time. X and y can both be negative 7. In particular, x and y cannot both equal 0. Okay, and here it is. That's what you get. This finishes up the section on multiplying, dividing, and finding domains for rational expressions. Equal signs must be valid, folks.